These are your 6-7 notes on radical equations and inequalities. In fact, I don't think we're doing the inequality part of that, so it just might be the radical equations. When you solve a radical equation, there's two different methods, so to speak. Actually, the second method is just a little bit longer version of the first method. So we have to undo, we have to get rid of the radical. So when you get rid of a radical, the inverse operation that you're going to use is either you're going to square both sides of the equation or cube them. Those are the inverse operations of squares and cubes. So you're going to isolate it first. You do not want to square a radical when there's other numbers on the outside, because then you'll have to square the whole quantity, and then you're foiling, and it gets to be messy. So add, subtract, multiply, divide, get the radical all by itself. Then you're going to square and cube both sides to undo the root. If it's a square root, like in number 1, you would square both sides of the equation. If it's a cube root, like number 2, see that 1/3 that we talked about? That's just the cube root. You would cube both sides. And then solve for the variable as usual using inverse operations. We always have to check our answers for extraneous solutions. I will tell you, extraneous solutions are solutions that are wrong, but you didn't do anything wrong in the mathematics. So you did everything right. You found the solution correctly, but when you plug it back into the equation, it doesn't work. This happens when you square numbers or cube numbers. If you square both sides of an equation and you turn a positive number into or a negative number into a positive because you squared it, sometimes that causes that extraneous solution. So an extraneous solution, once again, are answers that don't work when you plug them back into the equation, okay, even though you didn't do anything incorrect in the process. So for number 1, I need to isolate the radical. So right now, there's a 9 being added to the radical. So I want to subtract 9 from both sides, clean it up. So the radical x minus 1, or the square root of x minus 1, is equal to 6. And now I'm going to square both sides of the equation. Whatever you do to one side, you do to the other. And the square and the square root cancel on the left-hand side. So we're just left with whatever was underneath the radical, x minus 1. And when you square 6, you're left with 36. So now it's just a simple equation to solve. Add 1 to both sides. X is equal to 37. Okay, check our answer. I'm pretty sure I didn't do anything wrong mathematically. However, I need to make sure that it works. So if I plug 37 into here, you can use your calculator. Take away 1, you get 36. The square root of 36 is 6, and 9 plus 6 does in fact equal 15. So you always check with the original problem. It works. It's not extraneous. Let's try that again over here. Now, if you don't like the 1/3, you can write it as a cube root of 3. It doesn't matter because they'll both cancel out. So if you want to write that as the cube root of 2y minus 1 minus 3 is equal to 4. Now I'm going to isolate the cube root, add 3 to both sides, and so I have the cube root of 2y minus 1 is equal to 7. To undo a cube root, I need to cube both sides of the equation. And so the cube and the cube root cancel. 2y minus 1 is 343. That's what 7 cubed is. And when I add 1 to that, to both sides, I get 2y is equal to 344. When I divide both sides by 2, y is equal to 172. Okay, I'm going to check for extraneous solutions. So I can use a calculator. I don't need to see the check, but if you don't check it, and if the answer doesn't work, 172 is incorrect. If the answer doesn't work, you got to say no solution. So if I plug in 172 into the original problem here for y, 172 times 2 is 344. Take away 1 is 343. To the 1/3 power, or the cube root of 343 is 7. And 7 minus 3 does in fact equal 4. So you can plug that into your calculator and see that it's not extraneous. So that's basically the concept, but sometimes there's more than one radical in the problem. So that just sometimes causes some other issues. So if there's more than one radical, you need to get rid of one of them. So the other one's going to hang out. The problem's going to get really ugly. And then we just repeat the process. So we square cube both the sides of the equation, simplify, clean up. One radical, the one that you isolated, will go away, but there will be a remaining radical, so to speak. Sometimes they both go away. And then check your answers again. Repeat the whole process. So just a little bit longer. So if there's more than one radical, there's more than one. You got to go through this process maybe 2 times. So in this first example, because there's one on each side and there's no other junk with them, just cubing both sides will take care of both radicals. So if I cube this side, no problem. Cube this side, no problem. The cube and the cube root will cancel. 2x minus 7 is equal to x plus 2. We simply just bring over the x, subtract the x. At the same time I bring the x to the left-hand side, I'm just going to add 7 to the other side, do it all in one step. X equals 9. I'm going to check my solution. When I plug in 9, I get 18. 18 minus 7 is the cube root of 11. Okay, well, I want to make sure that I get cube root 11 on the other side. When I plug in 9, I get 11. So I get the cube root of 11 again, just to make sure. So 9 is the correct answer. If it didn't work, we'd say no solution. We'd throw it out. All right, I saved the best one for last. A little bit of a disaster here. So I have 2 radicals, and they're not the same radical. So I have to pick one to isolate. My advice to you is isolate the more ugly radical. So in this case, x minus 12 is all by itself. I'm going to leave it that way. So there's a 2 with this other radical. I'm going to leave it in that quantity, but that makes it a binomial. So when I go ahead and I square both sides, okay, I am squaring a quantity now. And if you remember, when you square a binomial or a quantity, it really means multiply by itself. So we're going to have to FOIL here, and they're not conjugates, so the middle 2 terms are going to be pretty ugly. So when I square the square root of x minus 12, they clean up. So there's the one radical that goes away. But in the meantime, the right-hand side is going to get a little ugly, but we'll fix it, we'll clean it up, and then we'll just get rid of the remaining radical. So to FOIL, 2 times 2 is 4. Outer term is going to give me a negative 2 root x. Inner term is going to give me a negative 2 root x. And last term is going to give me a positive root x squared. So it's a little ugly, but not too bad. So I'm going to go through x minus 12. I'm just going to leave alone. Okay, and then I've got this 4. I'm going to leave that alone. I have a negative 2 root x, and a negative 2 root x makes negative 4 root x. Remember, we add the outside terms. And then this positive x squared, square root of x squared, just becomes a positive x. So one of those radicals went away, okay, but we still have this remaining radical that we got to get rid of. So our next game plan is you treat this problem just like the beginning of the first. You isolate that square root of x. So we want to do everything we can to make that square root of x go away, or be by itself. So I see an x on both sides. If I subtract x from both sides, they cancel. That's nice. Okay, and then I'm going to subtract the 4 over as well. And when I subtract 4 over, the negative 12 and the negative 4 make negative 16. So I'm just going to clean up what I got. So this is what I have so far. Negative 16 is equal to negative 4 root x. Let's isolate it a little bit more. This negative 4 is multiplying the square root of x. So if I divide by negative 4, divide by negative 4, I get a positive 4 is equal to the square root of x. And now we're ready to just square both sides, and x is equal to 16. I'm going to check my solution, make sure it works. I go all the way to the top to check my solution. And when I plug in 16, I get 16 minus 12 is 4. Square root of 4 is 2. So I got 2 on this side. And when I plug in 16 here, the square root of 16 is 4. 2 minus 4 is negative 2. So 2 and negative 2 do not match. That means this is an extraneous solution. Okay, now some people think, oh, I did all that for nothing. Well, no solution is just as valid as 16 or 4 or negative 2. So you did all that to find the fact that there is no solution. You wouldn't have known that without showing the work. So you just put no solution. All right, so I want you to explain what an extraneous solution is in your own words, and I need you to solve that rational or radical equation. Good luck.